In this example, we are going to find the volume of a solid in the first quadrant generated by rotating around the y-axis. So that means everything is going to need to shift in terms of y. And these are not in terms of y, and so we'll have to manipulate them a little bit. But we just did a problem with the exact same equations, and we are rotating around the x-axis. And so we're rotating it around this way. This time we're going to take that exact same look, and we're going to rotate it around this way, which is going to give us a totally different shape, different look, probably a different volume. So let's start off with the fact that we would have this cubic graph would look something like this. Our linear graph would look something like this. And they intersect each other at 8. But I don't want the x value. I want the y value. So when I cube root 8, I get a 2. And so everything is going to be in terms of y's, which means this cubic equation, this y equals cube root of 3, I'm going to cube both sides. And that's our equation. And then our other one of y equaling 1/4 x, I'm going to multiply by 4. So 4y equals x. So our formula is now we're looking at this direction. We needed a big radius minus a small radius when we're doing the washer method, right? Big radius minus the small radius. So our big radius would actually be going all the way across. So it would be the linear equation. And so it would be the 4y equation. So if we start to set this up, we're going to go from 0 to 2. We're rotating around y-axis, 0 to 2 pi. Big radius is going to be 4y that we will square, right? Because here's our formula. So big radius squared minus little radius squared. So little radius is going to be that distance right there, which is in terms of y is a y cubed. So minus y cubed squared dy. All right, so let's start to do the math here. So let's clean it up, get it ready to do our antiderivative. Let's take the pi out, 0 to 2. This is going to be a 16 y squared. This is going to be a minus y to the 6th. And we're going to do our antiderivative with respect to y. So antiderivative is we're going to add a power, divide by that power. So we're going to take 16y cubed divided by 3 minus y to the 7th divided by 7. And we're going to go from 0 to 2. Okay, so let's plug in some stuff, see what we get. We have 16 times 2 cubed over 3 minus 2 to the 7th over 7. Right, and then that value, we're going to be subtracting the 0 being plugged in. So just a minus 0. Let me do the bracket on this to differentiate. There we go. All right, so 2 cubed is 8. 8 times 16. We'll still have our pi. 8 times 16 ends up being 128 thirds. 2 to the 7th also ends up being 128, but it's 128 sevenths. And so if I get a common denominator, I would multiply this by 7, which would make it 896 over 21. Multiply this by 3, I get a 384 over 21. And if I put that together, the 896 minus the 384 is 512. We'll tack our pi onto it now, over 21. All right, and that is our volume of rotating these around the y-axis. We would get a totally different shape than what we got up here. We got a totally different volume, even though the equations were the same. Our rotation is going to create a different looking shape, so it's going to give us a different volume. So that was an example. We had to turn everything in terms of y. We went from 0 to 2, not to 0 to 8, because everything is in terms of y. We needed a big radius and a small radius. to throw it into the formula.